All right, this is CS50, and this is already week 7. And this is the week where we'll continue where we left off with Python, introducing you to a bit more syntax and capabilities of the language so you can solve like interesting problems. But a lot of those problems increasingly are now going to involve data in some form. After all, if you think of most any website or mobile app or process nowadays that involves solving problems, it almost always involves some amount of data, and often data at scale, lots and lots of data. And so what we're going to see first today is that yes, you can use Python to solve all the problems past that we've seen, and also some data-specific ones, but sometimes it's just going to be annoying. It's going to be a little painful. It's just going to be more work than you might like to just get to some answer. And so today we'll, too, introduce you to a new language called SQL, Structured Query Language. And this is a language that, rest assured, is actually much smaller, relatively speaking, than C and Python. It sort of does less, but it does it really well. And it's a language for querying databases, storing data in it, updating it, inserting it, deleting it, and so much more. And it's the kind of technology that's used nowadays in, indeed, web apps and mobile apps, data science, analytics, and so much more. It's really good at storing lots and lots of data. Now, this is yet another language. And believe it or not, next week, we'll introduce you to 3 more languages, HTML and CSS, which are not technically programming languages. They're all about aesthetics and markup of information, but also JavaScript, which is, in fact, a programming language. But the goals here in CS50 really are going to be to empower you to program more generally. And indeed, when you're out there in the real world, some years from now, invariably, there's going to be some new, other popular language out there. And hopefully, in this week and next week and beyond, among the goals is not just to teach you these languages specifically, but again, like how to teach yourself the future languages that we've not even heard about just yet. So with that said, let's begin with a survey of sorts. If you go to this URL on your phone or laptop, cs50.ly/favorites, a very simple Google form awaits you that's just going to ask you a couple of multiple choice questions. So go to cs50.ly/favorites, and that should lead you to a Google form that looks a little something like this, asking you first, as of now in week 7, what is your favorite language among those options here? And then further down, one more question. If you think back on problem sets 0 through 6, what was, if any, your favorite problem set problem, be it in Scratch or C or Python? So answer those 2 questions. And in a moment, I'll flip over to my screen here where you'll see, and anyone who's used Google Forms knows, the spreadsheet that's collecting now this data. Microsoft Office 365 can do the same if you use one of those forms. And what you see here now is a spreadsheet in Google Sheets enumerating all of the audience's questions. Language is in column B, problem is in column C, and each row represents one student who has responded. A few of you were super eager for class today at 8:33 a.m. Eastern Time, 10:32, 11:10. OK, so now we're getting into the actual class time here. And if I scroll down, we'll probably see a few dozen, couple hundred answers by now. And yeah, so we're getting a whole lot of answers here. And I'm seeing some patterns emerge, but it's not necessarily obvious to the human eyes what those patterns are. Now, of course, you can use Google spreadsheets. You can like highlight the data, and you can create charts magically out of it. But you can only do what Google lets you do with the data. And same thing for Microsoft Excel or Apple Numbers. But wouldn't it be nice to just be able to manipulate the raw data, relatively simple though it is, to just answer questions about the data? Maybe long-term create your own charts, customize it just the way you want, rather than beholden to like software that's off the shelf like this. Well, how could we go about doing this? Well, let me propose that we treat this data set now as what we're going to call, for now, a flat file database. We'll see today that there's fancier databases, but the simplest database in the world is really just like a .csv file. And we saw that a couple of weeks ago in C. We wrote a bit of C code that used fprintf to write data to a file using commas as the separator. We didn't really do much more with CSVs at the time, though, because it's really annoying, painful, time-consuming, not fun to use C for something like that because of malloc and memory and all that stuff. But with Python, it's going to be much easier. And so anytime you have access to some data set where you can just like download it to your own Mac or PC or your cloud environment, it's sort of a candidate for now writing code to do something with the data. Maybe analyze it right away. If it's been human inputted manually, maybe you have to clean it up by doing a lot of find and replace, but not with your keyboard, but rather with code. And so let me go ahead and do this. Let me go back to my Google Sheet here that has all of the data that's come in now. And let me go ahead and download this via the file menu here. And let's see, download. And you can see a whole bunch of options. If most formats might be familiar, but today we'll focus just on this one, comma, separated values, or CSV. That's going to go ahead and download it on my Mac here into my own downloads folder. And now I'm going to go ahead and do this. Let me go ahead and pull up VS Code in the cloud here. And if you've never done this before, there's a couple of ways to do it. But the simplest way to upload a file to your code space, so to speak, is just to sort of drag and drop. That's going to magically upload it to the server there. And we'll see that, one, it has a very long file name, which I'm actually going to clean this up because that's going to be very tedious to type in my code. So I could either right click, of course, up here, but I'm going to use my Linux command. So let's move this file called cs50 2022 something or other. And let's just name it more simply favorites.csv. So all lowercase, no spaces, sort of good basics. Can we lower the mic a little bit too? And let me go ahead now and open up this file with code favorites.csv. I'll close my file explorer, and we'll see exactly the same data as before, but not quite as pretty as Google Sheets makes it be. Rather, we see here that I still have 3 columns, timestamp, language, problem, and then all of the values down below, including the timestamps and the answers therefore, but it doesn't have proper columns. It just has commas separating them. Now, we could very easily write Python code, just like we wrote C code, to manipulate files like this, either to write or read. But instead, let's do something that's a little more pleasant, which is indeed in the form of Python. So Python actually comes with native support for CSVs. It has indeed a package called CSV that just lets you read and write and do a whole bunch of useful stuff when it comes to CSV files. So let's go ahead and do something with this file. Let me go back here to VS Code. I'm going to close favorites.csv for now, but just remember in your mind that timestamp was the first column, language was the second column, and problem was the third. And notice because we're using commas, they don't, again, line up perfectly, but that's not a problem. There are 2 commas in every line, presumably. And I'm going to go ahead and now create a file called, how about favorites.py, so that I can start writing some code to manipulate this data. And let's do something simple. Let's just write a simple program in Python that opens this file, reads it, and prints something out, just as like a safety check that I know what I'm doing, even though it's not going to be useful. So in Python, if you want CSV support, you import CSV. And that gives you access to all the magical capabilities thereof. Let me now go ahead and use this technique to open a file in Python, which is similar in C. But with Python, I'm going to do this. The keyword with. I'm going to open a file called favorites.csv, which was the shorter name I gave it. This is optional, but just for explicitness, I'm going to open it in read mode explicitly, just like fopen took a second argument as well. And I'm going to name this file, once opened, quite simply file, though I could call it anything I want. And now it's just an open file. So far as Python knows at this moment, it's just text, or better yet, it's just zeros and ones. If you want this Python package called CSV to actually do something useful with it, you have to load this file now into the library. And the simplest way to do this is to give myself like a variable called reader, because I want to read this file, though this too I could call anything else. I'm going to then set that equal to the return value of a function called csv.reader. And I pass to that, per the documentation, the open file. So step 1, I open the file, and this just gives me access to the bytes therein. Step 2 now, with csv.reader, tells the Python package called CSV to do something useful with it and start analyzing the commas and allow me to parse it further. So let's go ahead and do this. Let me go ahead now, and within this loop, let's say this. Within this open file, let's do this. For every row, if you will, or line in the file, aka reader, let's go ahead and print out just how about row bracket 1. Now, what's going on here? Well, it turns out if you read the documentation for the CSV reader function, what it hands you back is essentially this special object, so to speak, that allows you to treat it as though it's just a really big list of lines from the file, aka reader. So by saying for row in reader, this is a way more succinct way of saying, give me the first line in the file, plus plus. Give me the second line in the file, plus plus, and so forth. That we would have done much more mechanically in C. This is just much more Pythonic and English friendly, if you will. So in every iteration of this loop, row is going to contain all of the data from the current row. But better yet, what the reader function does for me is it hands me each row not just as a big string or str of text in Python. It gives me what, apparently, based on the syntax on line 6? Any instinct? Yeah. It's giving me back indeed a list. And I presume the visual clue for you was the fact that we're using square brackets here. And indeed, row bracket 1 is going to be not the first, but the second element in that list. And so just take a guess. When I run this code in a moment, what's going to get printed? The timestamp, the language, or the problem? The language, because it's the second column that is in the file delimited by those commas. So let me go ahead and do this. Let me clear my terminal down here. Let me run Python of favorites.py and enter. And there's everything. It was super fast, but there's a really long list here. And in fact, if I increase the size of my terminal and start scrolling up, you'll just see all of the raw data. Now, this isn't that useful yet. I could have just glanced at the CSV, but clearly now I have the ability to open the file, parse it, so to speak, that is, break it up into its constituent parts, and do something with specific parts therein. All right, so if I want to do this a little more pleasantly, though, let me at least make this semantically a little cleaner. And you know what? Just for clarity, let me just give myself a variable. It's not strictly necessary, but I know that this is the favorite, for instance, language. So let's just call it favorite, set it equal to row bracket 1. And now just to be more explicit in my code, even though, again, we don't need the variable per se, this code's, of course, going to do the same thing. It's just using an additional variable called favorite. If I go down here, scroll up, run the program again, I get back the exact same data. But this is a stepping stone to something that's even more powerful about Python support for CSV files, is that you don't have to just treat the return value as a list with 0 and 1 and 2. So just thinking intuitively here, why is this maybe not the best design to hand you, the programmer, back the data in a list that's numerically indexed with 0, 1, 2? It clearly works, but critique this. What could go wrong? What's a little poorly designed? Yeah?
You have to always remember like what the things are, like what the order is. So
Yeah.
language, and then I forgot the last.
Exactly. So it's up to you to repeat. It's up to you to remember like what column the data is actually in. And God forbid you're collaborating with someone else on the spreadsheet. If you've used Google Spreadsheets, you can move columns around, maybe just because you want to visually reorganize things. And if you do this, and then someone else downloads that same data, all of their code is going to break. So that's just really bad design. It's fragile just because you're sort of on the honor system that 1 means the data that you want. So wouldn't it be nice if we could be a little more explicit? Well, recall that the very first line in this file is actually, and I'll scroll back up to see if, actually, let's do this. The very first line in this file is actually this. And I paused the output this time so that we can see more optionally. I just reran favorites.py. And notice one of these things is not like the other. Every output was either Scratch or C or Python, except for this first one. Why am I seeing the word language here? Where did language come from? You didn't have the ability to manually input. Oh, no? Where did it come from? Yeah. Yeah, the header, the very first row in the file, which by human convention generally just defines what the columns represent so that there's some human useful information there. Now, that's not really intended to be part of my output at the moment. So there is a way to skip this. If you want to skip the first row, you can actually do something like this. You can say next row, and that will just ignore that row so that I'm starting really with every row thereafter. But there's a better way to handle this than that. That will get rid of the row in the output. But let me go ahead and use a different feature of the CSV package that's just going to make this a little cleaner altogether. So let me clear my terminal window here. Let me undo this next thing that I just added. And instead of using a reader, let me go ahead and use a dictionary reader, abbreviated dict reader, that's going to now return me the equivalent of all of the rows, one at a time. So I can still call it reader just as before. But as the name implies, what this reader is going to return is not a list after list after list, but a dictionary, a dictionary, a dictionary. And remember, a dictionary is just a collection of key value pairs. So what does that mean? What are the keys? What are the values? Well, now that I'm using a dictionary reader, I can actually do this. Instead of sort of on the honor system remembering that I want column 1, I can treat row now, not as a list, but as a dictionary. And that means I can go in here and say, quote unquote, language. And we saw that back in week 6. Python allows you to index into dictionaries using square bracket notation in strings or strs on the inside, just like lists allow for numbers. But this now, I think, is going to be a little more robust. If I run this again, Python of favorites.py, All of that worked out fine. And let me pause the output too by using this program called more. Now I don't even see the header. So now whoever works it with Python wrote the code for this package to just analyze that first line of code, use the header, as you just called it, as the keys. And then every time you iterate through this loop, it updates the values, the values, the values, but the keys stay the same. Any questions then on this technique? Suffice it to say, this would be painful in C. Yes? Exactly. So the keys are always going to be, quote unquote, timestamp, language, and problem. But on each iteration of this loop here, the row is going to contain a different row of values, different row of values, different row of values. So you're going to get back one dictionary for every student who submitted the Google form, if you will, while iterating through it there. All right, so once we have this ability here, why don't we go ahead and transition to, how about not just using that dictionary reader, which makes the code a little more robust, because now if you move the columns around, no big deal. It doesn't matter if the numeric indices change. You can still use those keywords instead. But let's actually analyze the data now. I'm just spitting it out, which is not solving any problems for anyone. So let's go ahead and count the popularity of Scratch, C, and Python and see what everyone's been thinking here. All right, so how might I do this? Well, let me go ahead and do this up here. Before I start iterating, let me give myself, let's say, 3 variables. And to keep things simple, I'll say one variable called Scratch, set it equal to 0 for 0 students so far. C is going to equal 0, and Python is going to equal 0. There's a slightly prettier way of doing this, just because this is like 3 lines of code to do something very simple. You could alternatively, in Python, but not C, do Scratch, comma, C, comma, Python equals 0, comma, 0. So kind of slightly more elegant, just to fit it all into one line. But now let's just do something more interesting. On line 7, I'm still going to figure out what the current favorite language is. And now I'm just going to do some conditional checks. How about if that favorite equals, quote unquote, Scratch? Let's go ahead and increment Scratch by 1. We can't do plus plus in Python, but we can do plus equals 1. How about if favorite equals C? Then let's do C plus equals 1. And not, we could do else. This is actually a good design question. Should I do else? Should I do if? Any instincts here? Yeah. Yeah, really good instincts. Just in case someone goes and adds another language to the form next week, because we're obviously going to introduce another language today, you don't want your code to now artificially inflate the scores for Python just because you're conflating multiple languages together. So the more defensive, sort of better way to write this code, I agree, would be if favorite equals Python, then let's go ahead and increment Python plus equals 1. And if there's a new language next week, we're obviously going to have to update the code, but at least we're not miscounting. We're just missing the new language. So I think that's slightly more robust. All right, now at the very bottom of this program and outside of the loop, when I'm all done counting, let me go ahead and print out using some f strings. How about the total number of people whose favorite is Scratch? So this is just week 6 f string syntax. Let me go ahead and print out another f string for C. And I'm, of course, putting the variables in curly braces, all lowercase, but the English words I'm doing capitalization for. Let's do a final one with f, Python, colon, and then in curly braces, Python, close quote. And I think I'm done. So let me just hide my terminal for a second. Here's the total program. Same stuff as before. Open favorites.csv. Open it further with the dictionary reader to do that processing for us. Initialize 3 variables to 0, just so we have something to count with. And then iterate over the file, row by row. And this is just some sort of week 1 style conditional logic, albeit in Python, counting things. All right, so how can we now execute this? Let me go back to my terminal, Python of favorites.py. And here we go. As of today, everyone who's reporting in live via the Google form, their favorite languages are? Interesting. That's pretty interesting, too, after just 1 week of Python, no less. So, but Scratch is a healthy contender there, a lot of C, so a pretty good mix here. So is this going to be the best way to write this program? long term? Well, as you noted, if there's a new language next week, this week, we're going to have to constantly update this. And here's where you should let your mind wander to like the future. Like if we have a fourth language, fifth language, sixth, seventh, eighth, which aspect here might kind of have some code smell to it? Like this probably isn't the best design to set us up for the future. What might be better than this? Yeah? Yeah, we have to keep adding a language to line 5. And OK, not a big deal. We could add like SQL today and maybe JavaScript next week. But you know, anytime a line of code, a line of logic is just going to kind of grow out of control, and we've had this chat a couple of times with different syntax, there's probably a better way than that. So let's do that. Instead of using these individual variables, we could maybe use a list. But a list would be a little confusing because like what does bracket 0 mean? What does bracket 1, bracket 2? But a dictionary, recall, is like this Swiss Army knife of data structures whereby you can associate anything with anything else, keys with values. So I dare say a cleaner way to solve this problem that sets us up for less work or confusion later would be to create like a new variable called counts, if that's what we're doing, counting things up, and just set it equal to an empty dictionary. And you can literally say dict with the open parenthesis, close parenthesis, and nothing. Or the more Pythonic, just use open and close curly braces with nothing inside. That gives me an empty dictionary, just like square brackets gives me a list. Now, my logic down here has to change a little bit. But what's nice is I don't need one conditional for every language. Because again, if we have a fourth, a fifth, a sixth, that chunk of code is also going to grow a bit out of control too. So I can get rid of this here. And what I think I'm going to do is say this. Whatever the current favorite is from the current row in the file, why don't we go into our counts variable at that key. And again, favorite is a variable. It's not quote unquote favorite. It's going to be Scratch or C or Python. And then why don't we go ahead and just increment whatever the value of that count is at that key. Now, this is technically buggy. We're really close, but there is a bug. Does anyone want to conjecture what the bug is? Yeah.
Well, this is more a question, but like, will that automatically add a new key value pair for each language?
A good question that answers my question nonetheless. So no, like the magic you described will not happen. And to repeat the hypothesis, will this automatically create a key for every language that we try plugging into those square brackets? Short answer, no. Odds are this is going to create a key error, one of those traceback error messages that you've probably seen by now, either in class or in problem sets, whereby if Scratch hasn't appeared in the dictionary before, or C or Python, like then the dictionary has no clue what you're talking about. So I think we actually still need some conditional logic, but not that's going to grow longer and longer with each language. What I think we probably want to do is this. If the current favorite is in the counts dictionary, and this is the Pythonic way of just saying, is this key in this dictionary, then go ahead and safely do counts favorite plus equals 1. Else, to your conjecture now, else what do I want to do? Counts favorite equals, yeah, 1. So initialize a brand new key to a brand new value of 1, because I'm obviously just seeing this language. Otherwise, increment again and again. And now down here, I just need to tweak my syntax a little bit. I don't need to print out all of these things one at a time manually. I can actually get away, I think, with another loop at the very bottom here. So how about I do this? For each favorite in those counts, and this is, again, the Pythonic way to iterate over all of the keys in a dictionary, go ahead and print out, using an F string, whatever the current favorite is, Scratch or C or Python, and then a colon, and then figure out what its count is. And you can do that by going into the counts dictionary, looking at the favorite key, and get back its value. So I close my curly braces, I close my quotes, and even though this looks ugly at the moment, now this is much more dynamic, because if we go and add SQL to the CSV file tomorrow, or we add JavaScript next week, this will just work. It will keep working now automatically. All I change is the Google form, not my actual code. All right, let's try Python of favorites.py. Cross my fingers as always, and there now is the data as of now. Questions on this code here? Yeah? Really good question. What if you wanted to print it in a particular order? Well, I could give you a couple of solutions. Like if you want to print it out in It's already coincidentally in alphabetical order, so you got that for free, although that's just by chance here. But there is a way to do this. And let me propose that we go down here to my loop, and I explicitly use a function you might not have seen in Python yet, but it's literally called sorted, which is going to take either a list or, in this case, a dictionary, and by default, sort it by key alphabetically. Now, if my intuition's correct, this is not going to change the output because it's already alphabetical. But if you read the documentation for the sorted function, it takes multiple parameters potentially, some of which are named parameters. And so you can actually do this. If you want to sort the counts, but you want to reverse the order for whatever reason here so that it's reverse alphabetical order, now let me go ahead and rerun this. And I'll keep the previous output on the screen. Enter. And now it's backwards alphabetically, if you will. Other questions on this here? No? How about then we transition to sorting by value? And this is going to escalate a little quickly, briefly, but then we'll tone it down again. Notice that right now this is indeed sorting by key. What if, especially if I have lots of data, it'd be nice to make like a top 10 list, or in this case, a top 3 list, and actually see in order of the counts, the values, what these popular ones are. So it's not C, Python, Scratch. It should ideally be Python, then C, then Scratch because of the values and the magnitude thereof. So how can I do this? Well, it turns out there's another parameter that you can pass to the sorted function that is typically implemented as a function itself. And so I'm going to go ahead and do this. I'm going to temporarily define a function called getValue, just to make my life easier. And this getValue function is going to take, I'll say, a language parameter. And then all I'm going to do is return whatever the count is of that language. So out of context, this is just a super simple function that you handed a language like Scratch or C or Python. It's just going to tell you what the count is thereof in that dictionary called counts. But what I can do now down here in my newly introduced call to sorted is I can tell it what to use as its key. Instead of using literally the key, Scratch, C, Python, I can sort of override that behavior and say, you know what? To figure out what to sort by, go ahead and call this function called getValue. Notice that I have not put parentheses after getValue because I don't want to call getValue right then and there. I want to pass the getValue function as itself an argument to the sorted function so that the sorted function, written years ago by the people at Python, can call my version of getValue again and again and again when they try to sort this actual data. So now, if I add that and I leave reverse equals true, let's see what happens. Python of favorites.py, enter. And now I get my top 10, or in this case, top 3 list. And if I had more sophisticated data with like more columns altogether that I actually care about, I could even sort this more powerfully as well. But let me clean this up a little bit just so you've seen it, even though we won't use these that often in CS50 until the end of the class will they come up again. Technically, this is a little bit, this isn't necessarily the best design to spend all this time implementing a function and then only use it in one place. In general, we've argued that you don't necessarily need a variable if you're only going to use it in one place. You don't really need a function if you're only going to use it in one place. And here, we kind of have a good candidate for that. And so it turns out in Python, if you don't want to bother creating a function just to use it once, you can create what's called an anonymous function, aka a lambda function, like the lambda symbol, familiar. And a lambda function, the syntax is a little strange looking, but you say this. You literally say lambda. You literally then say the name of the argument that you want this anonymous function with no name to take. Then you have a colon. And then, quite simply, you write what you want the return value of this function to be. You don't even say return literally. These lambda functions are meant to be used super tersely so that you can, in one line, express something like this. And I admit this looks more cryptic, I think, than the previous version. But as you get more comfortable with Python or other languages that support this feature, it allows you to not bother with lines of code like that and just tighten up your code a little bit. So this line here, lambda, language, colon, counts language, is the one-line version of this. And you don't even need to bother picking a name for it. Lambda tells Python, I didn't waste any time thinking of a name for this function. So questions then on this technique of using Python to analyze data like this? Any questions? We're almost done with Python. Questions? No? OK. So why don't we make things a little more interesting, because we had a much juicier data set with the problems that we've assigned over the past several weeks. Why don't we go ahead and quite simply, I think we wrote pretty darn good code here. So I think we can pretty much just change a bit of it to say, let's see, if I don't want language, I want problem. And if I want to sort by not language but problem, I think that's it. I think if I didn't overlook something here, just by changing what column I'm reading the data from, and then just to be consistent, renaming my variables just so I know what I'm looking at, what will this program now do after those minor changes? What will I see when I run this? What would be the first thing I see when I run this? Tough crowd today. Yes? Yeah, the problem, the top problem. So the most popular problem, which I'm a little worried it might be hello or just scratch, but let's go ahead and see. So let me go ahead and open my terminal window. I'll even maximize my terminal window so we can see a lot. Let me go ahead and run Python of favorites.py. I'm going to go ahead now and cross my fingers that I didn't mess up and hit enter. And OK, great. We peaked early. So Scratch was the most popular program according to the data at the time I downloaded it. I'm sure other votes have come in since. Filter in week 4 was tied then with Tiedemann as well. Mario is a close third there, and so forth. So this is helpful for us on staff. That's not so much love down here at the bottom of the list. So it was a bunch of code to write, but now that we've written it in this very versatile, dynamic way, it's pretty good for just like crunching data and doing some analytics. But it's still a decent number of lines to have had to write manually. And this is where sometimes it isn't necessarily the right tool for the job, but rather the job that but rather a candidate for using some other language altogether, especially when it's not just a one-time program that you run and you want to see the answer. What if you want to take input from the user and answer questions dynamically, like a mobile app would, like a website would, like Microsoft Excel or Apple Numbers or Google Sheets would for you? Well, let's make one final change for now to this version of the program and actually take in some user input. So besides just loading all of the data into memory, let's go ahead and down below here, not just print out the top 10 list, if you will, but prompt the user for their favorite. So I'm going to use Python's input function, and I'm just going to prompt them with favorite, quote unquote, like tell me what your favorite problem, what problem you're interested in. And now let me go ahead and say if that favorite is in the counts variable, so you didn't type in something random that we didn't actually assign as a problem, then let me go ahead and print with a format string whatever that favorite is of yours and show you the actual popularity thereof by indexing into counts using that favorite as the key and printing this. So now it's a dynamic program. It doesn't dump all of the data and all of the summations. Rather, it's going to allow me to see what my choice of favorite is. And I'm going to go ahead and say, let's see, I'm a fan of Mario here. So enter. And indeed, we see the same value we saw a moment ago, but just for Mario. But the point now is that, 1, all of this is possible. 2, it's way easier and more pleasant than this would have been in C. This is still only 15 lines of code. And in C, again, there's the memory management. There's the iterating over the strings, trying to find the commas. There's just a lot more work. But honestly, even when you just want to answer a question like this in Excel, in Apple Numbers, Google Sheets, generally you can just highlight things. You can click a button and boom, you get your answer for summation or max or min or any of those sort of basics. Wouldn't it be nice if we weren't taking a step backwards as programmers and being sort of more powerful, and yet we now have to do more of the work? So maybe sometimes Python's not, or any language is not, the best tool for the job. And that's going to now allow us to introduce more generally something called a relational database, graduating from mere flat file databases like text files or binary files in which all of your data is stored to something more proper. But first, questions.
With in and for favorites in counts, is that case sensitive? Like if someone were to type like lowercase Mario, would it still return that it's in counts?
Really good question. To reiterate, if I were to, is this case sensitive? So if I were to type in Mario in all lowercase and hit enter, I actually get no such response. Now, that might be acceptable because the problem technically what is a capital M, but that's a little ridiculous to be that pedantic about the input. So how could we solve this? Any tips for how we could make this a little more robust? Yeah? OK, yeah. Yeah, so we could use a few different functions, one of which is called title, which will change it to title case, where it capitalizes, like in most English sentences, the first letter of that sentence. We could use capitalize. We could use upper. We could use lower. But indeed, we could just decide how we want to standardize the capitalization, either uppercase, lowercase, or some combination thereof, and just make sure that you change the counts themselves, make sure that you do the same to favorite, and make sure that maybe you keep a backup of the data if you want to show the original version that came from the CSV without presuming to just capitalize everything for the user. But indeed, that would be the most common scenario. You just make things case insensitive when doing those matches. Other questions now on Python before we leave it behind for the coming week? All right, well then let's introduce these relational databases. So relational database is what is a super popular way of storing lots of data. Like this is what the Twitters of the world, the Googles of the world, the Metas of the world use to store some of their data at scale. There are alternatives to relational databases. Indeed, today we'll talk about a language called SQL. There's also a movement, if you will, or an alternative generally called NoSQL, which is just the opposite. You don't use SQL. There are things called object-oriented databases and the like. But if you've ever heard of MySQL or PostgreSQL or Microsoft SQL Server or Oracle or MariaDB or a bunch of other products, both free and commercial, this is what they're talking about. Databases that are designed to store lots of data. And what's nice about relational databases is that they're really similar to the spreadsheets with which you were presumably familiar long before today's class. So a relational database is going to store, as you'll see, all of the data in rows and columns. Now, the terminology will thereafter be a little different. Instead of having sheets, you're going to have tables. But those tables are still going to have rows and columns. And you're going to have even more control over the performance of your data when you start to access it using this structured query language, or SQL. This is a language you can use for web apps, mobile apps. A lot of analysts would sit down at their Mac or PC and actually ask questions of data to get back the answer. And wonderfully, even though there will be some new syntax today, SQL really just does 4 basic things. CRUD is the sort of crude acronym here. CRUD is a way of remembering that a relational database supports ultimately creating data, reading data, updating data, and deleting data. So even if you're feeling like, wow, this is a lot of new syntax, which it isn't relative to our past languages, the only things you're doing really are creating data, reading data, updating, and deleting the same. Now, a little confusingly, in SQL, the corresponding functions or commands that exist that map to CRUD are actually this. So it's still create, but there's another one called insert. It's not read, which is more of the computer scientist way of saying it, but select, which is a little more explicit, like select data you care about. Update is still update. Delete is still delete. But there's another command called drop, which lets you drop, that is, delete entire tables as well. So you can create tables using syntax that's generally going to look like this. You'll say create table. You'll give the name of the table, which you can call most anything you want, but generally all lowercase, no spaces is best. Then in parentheses, you can specify a comma-separated list of the columns that you might want in this table. So this is the code equivalent in the SQL language of like manually opening Google Sheets or Excel or Numbers and like clicking in the top left cell and like typing timestamp. And then in the next, typing language. And then in the third, typing problem. This is the way to sort of define what your headers are, if you will, in a spreadsheet, but now it's called a table. Now, we won't use this command manually first. Let's do something a little simpler. We're going to start off by just importing this data ourselves. And I'm going to go ahead and do this. Let me go back to VS Code here. I'm going to leave behind favorites.py for now, because now we're going to transition to this other language called SQL. And to do this, I'm going to create a new database file. And I'm going to do so using a command called SQLite3, which is just the third version thereof. And I'm going to give the database a name of favorites.db. There's different conventions, but this is one of the most common. When I hit enter, this is going to create for me a new empty database, just like opening an untitled spreadsheet in Excel, Google Sheets, or Apple Numbers. I'm being prompted, do I want to create favorites.db? I'll hit Y for yes. OK. we're up and running. Now you're going to notice a different prompt. I'm not in my Linux prompt per se, which is always the $sign. I'm now inside of the program called SQLite. And we're going to use SQLite 3, as just an interactive way for now of playing with SQL code. At the end of today, we'll show you how you can use SQL in Python code so that you still write Python code to do whatever you want, but you can talk to databases using Python. And this is exactly how web apps, mobile apps work. For instance, on iOS, on an iPhone, an iPad, or the like, if you want to store data, it's very often stored in a SQL database, as we're about to do. But you might use a language called Swift or Objective-C. And the same exists in the world of Android using Java or Kotlin or something else to query the database. So we're going to see SQL in isolation for now. Like an analyst might just use it, their Mac or PC. But we're going to tie it together by day's end. So at this terminal, SQLite, let me go ahead and execute this command first. I'm going to first put SQLite into CSV mode because I'm going to cut some corners initially. And I'm just going to automatically import all of the data that was submitted via that Google form, which I exported as a CSV and uploaded to my code space. And I'm just going to automatically say, turn this CSV file into a SQL database for me, just so I don't have to figure out what those create table commands are. So to do this, I'm going to say mode CSV, so that SQLite knows that this is the command, knows that this is a CSV file. It's literally dot mode, so the dot comes before the keyword there. And now I'm going to say dot import, and then the name of the file I want to import, which is favorites.csv. And now the name of the table that I want to create with that data. And just for consistency, I'm going to call it favorites. I could change these things to be anything I want, but I'm going to do that. And voila, nothing seems to have happened. But just like in C and in Python and Linux, when nothing seems to happen, that's usually a good thing. It means I didn't mess up. So if I want to see what just happened, there's this other command. And these commands that start with dots, these are SQLite specific, which is indeed a lightweight version of SQL. They're not SQL per se. So if you're using Oracle or something else like that, you're not going to use these exact commands. You'll see the ones we use in just a moment. And here's the first. When I type .schema, the schema of a database is the design of the database. What are the tables? What are the columns? And all of that. So when I type .schema, this actually, in this case, shows me the create table command that was automatically run for me by just doing this import line. Once I get more comfortable with SQL, I could literally type this out myself or use some program to generate that as well. But what it's creating for me is this: create table. If it doesn't exist, even though it's more terse than that, I want to create a table called favorites. And then the columns for that table are going to be timestamp, which is going to be text, comma, language, which is also going to be text, comma, problem, which is also going to be text. That was just inferred very trivially by the .import command to just figure out that, yes, just give me a 3-column database table based on the Google form. Okay, questions on this? These are commands you run once to get up and running. You don't run these commands frequently. But we have them on the slide just for reference. All right, so now let's do something a little more interesting. I'm going to clear my SQLite terminal here, but I'm still in SQLite. I'm going to now use some of my first SQL commands, which recall were among them select. So CRUD, C-R-U-D, the R was select. This is maybe the most common, the most useful, the most powerful thing to use with a SQL database, selecting data to answer questions akin to the ones we were trying to answer with Python. This is the general syntax. Anytime you want to select data from a SQL database, you literally say select. You then specify the column or columns that you want to select data from. You literally write the word from, and then you specify the name of the table you want to get that data from, semicolon, in this case. Everything that's in capitals here is a SQL keyword. Strictly speaking, you don't have to capitalize things, but we would encourage you to do so stylistically. And especially as you're learning, and even as you're writing it, it just helps to distinguish SQL from like words you chose, like the names of the columns and the data therein. So do adopt early on this convention. So let me go back now to my code space here. I'm running my terminal window with SQLite 3 inside of it. Suppose that I just want to get all of the data from the favorites table, which was automatically imported. Let's do this. Select. I want everything. Well, I can do timestamp, comma, language, comma, problem. But you know what? Here's a convenience already. If you want everything, there's what's called a wildcard character in SQL, which is just a star, an asterisk, which means give me every column without my knowing even what they're called. Let me go ahead now and say from favorites, semicolon. And this is the SQL way of opening the database, iterating over every row they're in, printing out every row they're in, done. So those 3 steps, which was like 9 lines of Python code, give or take earlier, is now 1 line of SQL. I hit enter. There is all of the data. So I see now all of the data just outputted as a CSV here. But it's not the CSV file. It's now actually the table. And in fact, just for good measure, let me do this, because you'll see the behavior a little differently the next time we open the file. I've just exited out of SQLite 3. I'm going to rerun it. But I'm not going to re-import the data or do anything like that, because my file now exists. In fact, let me take one step back. If I type ls at my Linux prompt, there's my favorites.py from before. There's my favorites.csv from before. And here's a third file that I did create a moment ago when I first ran SQLite 3. So the data is persistent. It's not using RAM or memory. Anything I do now is saved there. So let's go ahead and rerun SQLite 3 with the same file. But I don't have to re-import everything because the file already exists. Let me now do that same thing again. Select star from favorites to get all of the data. And what you'll see now is the same data, but it's a little prettier now. Because I reran it, I effectively disabled CSV mode this time. And what I'm now seeing is the entire contents of this database table called favorites. Now, there's nothing new here, but you're just seeing now like an ASCII or Unicode version of all of the same data from that database. Well, suppose I want to get a subset of the data. Well, let me clear my screen. And just like in Linux, I can hit Control-L just to clean things up aesthetically. Suppose I want to get just the languages. So I could do select language from favorites. And this will now select not all 3 columns, aka star. This will only select the language column and all of the data therein. If I hit enter, voila, now I just see those there. No timestamps, no problems. It's just a slice of the table, if you will. All right, not that interesting still, because it's just a big column of data. But now things get more interesting. It turns out in SQL that there are functions that come with this language, just like C, just like Python. In SQL, some of the more useful ones, some of the simpler ones are these here. Average, count, distinct, lower, max, min, upper, which pretty much do what they say. And count is a particularly useful one. Let's start with that. You know, it's a reasonable question to be asked, how many people submitted the Google form by the time I actually downloaded the CSV? Well, why don't we go ahead and do this? Let me go back to VS Code here in my terminal window. Let me select not star, but the count of star. So give me the count of the rows that are being returned from the database called the database table called favorites. Now when I hit enter, I'm not going to get all of the data. I'm just going to get simply a number. 430 rows came back. So that's pretty good. I now know how much data is in there. Well, what languages were in there? Well, I could do select language from favorites just as before, but that's not that useful, especially if I'm inheriting the data. Like I'm the analyst who's been handed a data set by my boss, and they want me to like crunch some numbers. OK, I could like load this into Excel. I could sort it. But you can use SQL now to answer pretty basic questions too. If you want to select the distinct languages in the data set, because you weren't privy to the Google form, let me go ahead and select only the distinct languages from the favorites table. And now I hit enter, and I get back a much more succinct answer. Just the 3 languages in question. Not really that useful since I created the Google form, but certainly if you're inheriting data from someone else, you've just downloaded a data set, at least now I'm arguably wrapping my mind around what's going on. Now, this is not necessary for such a small data set, but I can combine these things. Select the count of the distinct languages in this data set called favorites, and now I should get back what answer? So hopefully, indeed, an answer called 3. And what you're getting back, notice, aesthetically too, is like a mini temporary table. When I asked for just the distinct languages, what SQL hands me back is this temporary table in memory that has 1 column called language and then 3 rows. Now, this is not saved anywhere. It's just executed ephemerally like this. But that's why it's depicted in this way. What you're getting is subsets of your data, smaller tables containing some of your data. And same thing down here. This is like a crazy long column name. You can rename it if you really want. But that's all we're seeing there. And in fact, if that's a little ugly, we can actually alias these things. N is a common name for a variable, a number in any programming language. So I can actually alias this to be a column called n, hit enter, and now I'm getting a tiny, tiny table whose column is called n that just has the one value there. All right, questions on these, application of these functions here? No? Questions? Yeah. Say a little louder. Oh, as, literally in English. So name this column, rename this column as this. Technically, it creates an alias for the column. So that's all. Yeah. Exactly. Distinct will operate on whatever you handed in parentheses and get rid of all of the duplicates, giving you back just the uniques. Correct. Other questions here? Yeah.
When n becomes an alias in the table, does that become someone of a variable that you can call back to later on in the program? Or?
Good question. When you define an alias like n, which I just did, does it become like a variable you can reuse? Short answer, no, in this case, but you can reuse it within your same query. Even though these queries are getting a little longer, admittedly, statements that they are, you can actually reuse n in even longer queries, so later in your query. And we'll see a few that are going to start to grow in length. So it's a nice way of nicknaming things just to be a little more terse in your query. So we can transition to some of these more sophisticated queries because it turns out there's some other techniques we can introduce as well. Here are some other keywords in SQL. And again, even though like this is another list of things, there's only 4 things fundamentally we're doing: creating, reading, updating, and deleting data. These are just allowing us to like fine tune how we do it exactly. So where is going to allow us to filter data, as we'll do in just a moment. Like select data where this conditional is true. Like is going to be an alternative to an equal sign. So instead of looking for exactly Scratch or exactly Python or exactly C, you can look for something like ... And it can be a little bit of a fuzzier match, if you will, with other characters as well. Order by is going to deal with sorting. Limit is going to just let me limit the total number of rows that come back to 1 or 10 or finite if I don't want to see all 400 plus rows all at once, because I'm just trying to wrap my mind around it. And group by is best shown by example. So let's play with just a couple of these as well. Let me go back to VS Code here. I'll clear my screen. I'm still in the same SQLite instance. And let's count how many of you liked C without writing Python code as before. So let me go ahead and select the count of the rows from favorites where the language in each row equals C. And the convention in SQLite is to use single quotes anytime you're surrounding a string that's meant to represent a literal piece of text, as opposed to C, which was double quotes, or Python, which was either. So this is selecting the count of rows from favorites table where the language in question is C. Enter, and this gives me 98. Notice, though, if I omit that predicate like we did before, you'll get back the total number of rows that were in the table. So where is what's called a predicate that just allows me to filter things, just like an if condition or the like in a language that we've seen before. You can be a little more specific, like how many people really liked C and the Mario problem specifically. Well, let's do this. Let's go ahead and do select the number of rows from the favorites table where the language is C. And, so it's still literally the word ands and or, just like in Python, but not like in C. And problem equals Mario. So let's see if there's any fans of both C and the Mario problem. And 3 of us really like those 2 things together in this case. All right, what else can we do? Well, more compelling might be to see, kind of like in Python, for each language, what was the popularity thereof? And at the moment, we don't really have a way of doing that except in Python, where we had the loop and we had those variables with the dictionary that did all of that counting for us. You know, totally doable, but tedious, especially if your job is to analyze data. My God, like even writing 15 lines of code to answer simple questions is kind of ridiculous. SQL can do better for us. So let me go ahead and do this. Let me go ahead and select every language and the count thereof from the favorites table, but this time group by language. So this was another one of the keywords that we can use in this abbreviated list of extra features of SQL. And this one's takes a moment to wrap your mind around, but this is going to give me a 2-column temporary table where the first column is a language and the second column is the count thereof from this data set. And group by language just means that only show me Scratch once, only show me C once, only show me Python once. That is, group all of the identical values together, but keep track of how many of them there are. And so now, if I go over to SQLite and I hit Enter, now I have, in SQL version, the exact same output that I had from Python that took me, what, 15 plus lines before. Now we're down to just one, because SQL, structured query language, is all about constructing queries like this to answer questions and get back answers quickly. If we want to clean this up a little bit, you asked earlier about sorting order. Well, we can do that too. There's another key phrase we can use here. We can order by the count of those rows and then run that query here. So now, unfortunately, they're from smallest to biggest, but we can reverse that. It turns out, and my query is starting to wrap here. I'll zoom out for a moment. If you want to order by count, the default is in ascending order, abbreviated ASC. If you want to reverse the sort in SQL, instead of using reverse equals true like we did in Python, you say DESC for descending order. And now we get almost the same output, but flipped in reverse. So it's just a lot faster to answer questions once, of course, you get some muscle memory and some comfort with it. Well, what else can I do? You know, what if I just care about the most popular language? I don't care about the second place or the third place languages or anything else. Well, let me add one more clause here. Limit the answer to 1. And no matter how many rows should come back now, I just get the number 1 language as of the data set we collected with 270 votes for it. Questions on this? Any questions here? No? Well, what if, we're starting to introduce SQL, and it was kind of too late to make it into the Google form. So it turns out there's syntax for this too. You can create data, of course, not just the tables, but the data they're in. And here's like the typical syntax for inserting data into a SQL database. You literally say insert into the name of the table. And then in parentheses, you specify one or more columns for which you have values that you want to insert. This is to say, you don't have to give values for every column in the given row. If you only have answers to some of those questions, you can enumerate them here like this. But the values you insert are going to be these. So you literally say after the close parenthesis, values, and then in a second set of parentheses with the same length comma separated list, you specify what values do you want to insert. So it's a little verbose. And frankly, longer term, you're going to use like Python code to automatically do these kinds of insertions. But let's go ahead and try this. Right now, if I do select distinct language from favorites again, we see this, just these 3 candidates. But we've now taught you a bit of SQL, so let's do insert into favorites, the column called language. And you know what? I'm going to give a problem here. The values for which, and let me zoom back out, are going to be quote unquote SQL and quote unquote 50ville. You'll soon see what that's all about. Semicolon. Nothing seems to happen, but that's usually a good thing. And now if I scroll back up in my queries, in SQLite 3, you can scroll back and forth in time and, to avoid retyping things. Now I should see, indeed, 4 candidate languages here. Now suppose that you were never really a fan of C, and maybe you programmed a little bit in high school or in the real world, and you liked C++. Well, there's a whole lot of answers for C. So select star from favorites where language equals quote unquote C. So here's everyone who submitted the answer for C. Let's presume that no, they didn't really want C. They wanted C++, which is not a language we teach in the class. But I could also now do this. You can use the update command to set a column or columns to different values where some condition is met. So if I do update table name, set column name equal to some value, filtering it perhaps by where some condition is true. So suppose I've changed my mind, or you know what, let's go ahead and do update favorites, set language equal to maybe C++ where language equals C. Now this is destructive, so you generally don't want to do this unless you have a backup of your data too, overriding what people's answers are. This seems to have been successful because no error messages. And if I rerun the previous select that gives me all of the favorites where language equals C, now indeed I get none. But if I search for C++, now I get a lot. And if I get rid of that where clause altogether and just look at the contents of my database, now you see that indeed C++ is commingled with all the other data. This is not what you all intended, of course, so I can undo this. Let me go ahead and undo what I just did. Let me set my favorite language to C, where language equals C++, but the predicate is important. This I'm not going to do. What if I accidentally omitted this predicate, the where clause? How would that screw things up, might you think? Yeah, and back. It would set every row's language to indeed C. And this is dangerous. And if you start Googling around for like SQL mistakes or the like, people in the real world have accidentally run commands like this. And without naming names, a former member of our teaching staff at one point accidentally ran a command like this and changed every student's name in our database to Bobby, I think it was. The same name for every row because they simply forgot a predicate. So here too, like there's dangers in code. And you should adopt the habit quite quickly of always, one, backing up your data, like with CP, for instance, in Linux, or any other technique, or just making sure before you hit enter that, yes, this is indeed the query I want to execute. And generally speaking, in the real world, there should be process controls in place, like the intern should not have access to the database, the production database, the live database, and the like. But you have a lot of power now with these queries, so just be all the more careful, because very easily can you do bad things. So let me undo this. Where language equals, quote unquote, C++, and I'll zoom back out, enter, and now I think we're back in business. C is among the answers. Yeah? Is essentially doing what at the end? It's essentially find and replace. Yes, in like layperson's terms, this is find and replace implemented with SQL. And in fact, the authors of Microsoft Word or Google Docs might very well be using language like this SQL. When you go to the nice graphical, user-friendly find and replace box, this may very well be what they're doing underneath the hood. Or, of course, they could be using some other language altogether. There's one last syntax that's worth knowing, delete, which for better or for worse is even more destructive, whereby it allows you to delete rows from tables. It's distinct from drop, which lets you delete tables themselves. This focuses on rows. So suppose that you really, really didn't like, let's say, Tiedemann was a little challenging if you tackle that more comfortable problem. So if you really don't want to even think about Tiedemann anymore, so why don't we do delete from favorites where problem equals, and I won't execute it for real, Tiedemann. This would have the effect of deleting every row, including the language therein and the timestamp, where the student answered Tiedemann. Worse than this would be this. Why might this be bad? OK, chuckling, because like there's no predicate. There's no filter, which means literally this would delete all of the data. So again, with great power here comes great responsibility. Now, this has just been a data set of what, 430 rows by us dynamically created. There's, of course, some really juicy data sets in the real world. And one website you might have heard or an app you might have used is IMDb, the Internet Movie Database, which wonderfully makes some of their data available for download as CSV files or technically TSV files, tab-separated values. But what we did in advance of class was download some of that data for both TV shows in the real world and movies in the real world. And what's wonderful about this data set is it's not just dozens or hundreds or even thousands of lines. There are millions of rows of juicy data, TV shows and movies with which most folks are probably familiar, at least with a subset. And we'll see in just a little bit that this data comes in the form of now 6 different tables that we've given you. And the tables in question for today are going to be the people in the TV business, the stars therein, the shows that people are producing and the like. This is a picture we'll revisit to enable you to wrap your minds around what the actual data is. This feels like a good opportunity, though, for a snack. In fact, in just a moment, we have a whole lot of Rice Krispie treats out in the lobby. But if folks could perhaps acknowledge this mini wedding cake here. CS50's own Carter Zenke is getting married this week. So congratulations to Carter as well. Congrats. All right, there's only... OK, there's only one piece of cake in that box, but a lot of Rice Krispie treats in the transept. Let's take 10 minutes, and we'll be back with Internet Movie Database in 10.